If you are from electronics background, you might have came across this component, and this is called relay module. But most of the people don't even know that this relay module comes in two variants. First one is low level triggered and second one is high level triggered. And in this video I am going to test the relay module that you have, whether it is a low level triggered or high level triggered. So let's get started. So the relay module that I have right here is two channel relay module, because two modules are combined on a single PCB board. And at the back of these modules you can see total 6 pins. The starting 3 pins are for this module and the last 3 pins are for this module. And in this project I am using the last one. So the pinout of this module is something like this. The middle pin of both the modules, this one and this one, are labeled as common pin. Okay. And the right one pins, that means this one and this one, are labeled as normally closed pin, that means NC, and the left pin, this one and this one, are labeled as normally open pin. And by default, when you are not powering this relay module using any microcontroller like Arduino, the common pin and the normally closed pin are connected to each other. Okay, let me show you the visual proof. So here is a multimeter. I have set the mode of this multimeter on the continuity mode. This is the continuity mode. So when I will touch the probes of this multimeter, the black one and the red one, on the common pin and the normally closed pin, the buzzer will beep. Let me touch the probes on the pins. So I hope you can see the beep sound from the multimeter. Okay, you can see I'm touching the probes on the common pin and the normally closed pin. If I touch the probes on the normally open and the common pin, the buzzer will not beep, because by default these two are separated from each other. But the common and the normally closed are connected to each other by default. Now let's discuss the types of relays. So the first one is low level triggered relay. In this type, the relay is switched on whenever the microcontroller sends the low signal to its input pin. And high level triggered means the relay will be switched on whenever the microcontroller sends high signal to its input pin. So you can see this is the pinout of the relay module, and we have two input pins here, in 1 and in 2. So in 1 is for this module and in 2 is for this module. Okay, and we also have two LEDs at the bottom, this one and this one. So whenever the relay is switched on, these two LEDs are turned on. So suppose we are using this module in this project. So we will use in one pin here. Okay, so this LED will be turned on. So the relay module that I have is a low level triggered relay. And how do I know it? Let's test it. So we are going to use this program in our project, and this code is very similar to the blinking code for the LED. Although I am not going to use this project for blinking the LED, as I have imported this program from examples, basics and then blink. That is why it is showing blink.ino. Anyway, I will demonstrate you by sending both the high signals as well as the low signal on the relay module. So first of all, let us send the high signal on the relay. Let's upload this. So now you can observe that when the microcontroller is sending the high signal on the input pin of the relay module, the LED is not turning on. It means the entire relay module is in the off state. Now let us try sending the low signal. Now let's uncomment this low signal and comment this high signal. So this time we will send the low signal on the input pin. Let's upload the program. So now this time you can observe that when the microcontroller is sending low signal, the LED is always in the on state. Okay, and whenever the relay module is in the on state, the normally open pin is connected with the common pin. Let me show you the demo. So the multimeter is set on the continuity mode, and I'm going to touch the probes of the multimeter, one on the common pin, another on the normally open pin, and you can hear the beep sound from the multimeter. But this time the normally closed pin, which is this one, is disconnected with the common pin. If I touch the probes on these two pins, normally closed and the common pin, you will not hear any beep from the multimeter. Now let us establish the connections among the relay module, battery supply and the load. Here load is this solenoid lock. And the connection among all these three components is very similar to connecting a switch with the load and the battery supply. So here relay is basically electromagnetic switch, and inside this blue compartment there is a electromagnetic coil. Okay, and whenever you send the high signal or the low signal from the Arduino to the relay module, the common pin gets connected to normally open pin or normally closed pin, right? So I am connecting the black wire of the lock with the common pin of the relay module, and connect this red wire of the lock with the positive terminal of the battery. And we need one more wire which will be connected between the battery supply, that means ground of the battery supply, and the normally open pin. You can also connect this other end either to the normally open pin or normally closed pin, which is this one. So I am connecting this to the normally open pin. So I have already connected the input pin of the relay module with the digital pin number 7 of the Arduino, and obviously the ground and the VCC of the relay module are connected to the 5V and the ground of the Arduino. So this is the complete connections among all the components. So if you enjoyed this video, subscribe to my channel and like this video, and I also share some tips and tricks regarding the projects on my Telegram channel. You can join it using the link in the description, and also share your thoughts for this project in the comment section, and I will meet you with the new project in my next video. Till then, goodbye.